Okay, in this little chapter we're going to start talking about vectors. We've talked about these in class several times, but here's all the nuts and bolts about vectors and how they combine together. All physics quantities can be divided into two categories. It's either going to be a vector or a scalar. So everything that falls into one of these two categories. We're most interested in vectors. Vector quantity is a quantity that requires both magnitude and direction. We've talked about this in class. Magnitude and direction. So velocity and acceleration are these. They have a magnitude, 25 meters per second, and then a direction to the north, to the right, to the south, something like that. Scalar quantity just has magnitude. It is only magnitude. There is no direction associated with it. An example of that would be speed, because you can go 25 meters per second, no direction. So, test your understanding of this distinction. Consider the quantities listed below. Categorize each quantity. 5 meters. Is that going to be a vector or a scalar? 30 meters per second east. Vector or scalar? 5 miles north. Vector or scalar? 20 degrees Celsius. Vector or scalar? Scalar, vector, vector, scalar. Okay, vectors are going to be drawn with arrows, and when we draw these out, you're going to make the arrow be as long as the vector should be. So if you have a big number and a small number, the arrow for the large number should be longer than the arrow for the short number. The direction of the vector is the same as the direction of the arrow. A large magnitude is shown with a long arrow, and a short magnitude is shown with a short arrow. The magnitude of a vector in a scaled vector diagram is depicted by the length of the arrow. The arrow is drawn a precise length in accordance with a chosen scale. Vectors can be added and subtracted, so we can figure out how far something is or how fast something's going. If you look at our examples here, we have two vectors going the same direction. If they're going the same direction, they can be added together, giving you 10. We have vectors going opposite directions, so this one that's going opposite is negative. When you add those together, you get 0. Here's two that are going the same direction again. Add those together and you get 15. Opposite directions, this one's a negative 10, so you're subtracting, you end up with a negative 5. Opposite directions again, this one's a negative 15, so you end up with negative 10. Here's going up and down. So we have up with 10, down with negative 5. Add those together and you end up with 5. The resultant is the vector sum of two or more vectors. It is the resultant of adding vectors together. So what we just did in the other page, we found the resultant when we added two vectors together. The order in which two or more vectors are added does not affect the outcome. It doesn't matter which order you add them in. You can put the negative number first or you can put the negative number second. It doesn't really matter. The Pythagorean theorem is a useful method for determining the resultant of adding two vectors, and only two vectors which make right angles to one another. So if you've got the right angle, you'll have a vector here and a vector here. You could find the resultant by using Pythagorean theorem. And just in case you don't remember the Pythagorean theorem, it's a squared plus b squared equals c squared, where c squared is always going to be your hypotenuse of the triangle. A hiker leaves the camp and hikes 11 kilometers north and then hikes 11 kilometers east. Determine the resulting displacement of the hiker. So our first vector is 11 kilometers north. Our second is 11 kilometers east. So if we put these two lines together, we have 11 kilometers. We have 11 kilometers. Now we need to find out what the resultant vector is. So 11 squared plus 11 squared equals r squared gives us 15.6. That should be kilometers.